Hi. In my previous video, we had discussed about the basics of vectors, how to represent the vectors, and also the resolution of vectors along the horizontal and vertical. We ended up that first video with a few numericals to check the assessment. I promised you that we will be doing them in my next video lesson, and so here it is. Find the horizontal and vertical components of velocity of a ball being thrown in northeast direction with a velocity of 20 meters per second. That was the question asked. We can model the velocity of the ball thrown in northeast direction in this way, right? It is length is 20 meters per second. Northeast is represented by this 45-degree angle, and 20 meters per second is the magnitude of this vector. So horizontal component would be the magnitude of this line, the length of this line, and vertical component will be the length of this line. How can we find that out? We already had discussed the formula. Horizontal component is V cos theta. We substitute that 20 cos 45, which is nothing but 10 root 2. Likewise, the vertical component is V sin 45, 10 root 2 meters per second. The second question that we had discussed, which we had encountered, was horizontal and vertical components of force of 10 Newton being applied at an angle of 135 from x-axis. We can model the force in this way. Remember, the angle has always to be taken in the positive direction with respect to x-axis. And we have this being the vertical component and this representing the horizontal component. We use the same formula. FH, or horizontal component, here is F cos theta, 10 cos 135. And from trigonometry, we know that cos 135 is minus 1 by root 2, cos 90 plus 45, which will be minus 1 by root 2. So we get this minus 5 root 2 Newton, indicating that the force is acting towards the negative direction of the x-axis. And FV would be F sine theta, which will be 5 root 2. Here, this plus sign would indicate it is acting in the positive direction above the x-axis. What is the vertical component of a box being pushed along x-axis with a force of 10 Newton? We realize that this force is force along the x-axis, so this will not have a component along the y-axis. So vertical component is going to be F sine 0 or 0 Newton. So these were the simple quick check assessment questions. Now we'll move on to this lesson. In this lesson, we would like to discuss about how to add vectors, right? So in vector operations, addition of vectors is primary. These vectors can be in the same direction or opposite direction when they are collinear. How do we represent them? This is the case of a box being pushed by two people in the same direction, 10 Newton, 15 Newton. The answer would be that the addition of vectors will be 15 Newton and it will be towards the positive direction of x-axis. Whereas in this case, you have a force of 10 Newton along positive direction of x-axis. Here it is 5 Newton along negative direction of x-axis. The addition of vectors will lead to plus 5 Newtons along x-axis, because here it is 10 minus of 5. Minus 5 to indicate that this is a vector which is acting along negative x-axis. So 10 minus 5 would be plus 5 towards positive direction of x-axis. Then addition of vectors where they are not collinear, right? They are having different directions. How do we do that, right? An example for this is if I have a vector A, 5 Newton, acting at, let's say, 45 degrees with respect to x-axis, and B, 10 Newton along x-axis. How do I find out the the resultant of both the vectors. When we say resultant of A and B, essentially we are saying what is A plus B. So how do we add them up? First, let's understand or model these two vectors. A, 5 Newton with 45 degrees. B, 10 Newton along x-axis. The methods that we employ will be two methods. First method is called the triangle law, and there is a second method called parallelogram law. What does triangle law of vector addition state? It states that when you have two vectors which are acting simultaneously, you can model them as two sides of a triangle. So in that, you first draw the first vector. Our first vector is 5 newtons, making an angle of 45. From the end tip of the first vector as starting point, draw the second vector. So the first vector's end tip is here. So from this point, we are supposed to draw the second vector. We have it here. So AB is the second vector which is drawn. What does the triangle law say? You want to add OA and AB, then connect the starting point of the first vector with the end tip of the second vector. That means you have to join O and B. So OB is the desired sum. So we have to calculate OB, and that would give us the resultant, or A plus B. Now the method to calculate OB, we can do it using two methods. First is a graphical method. Graphical method is not very important for us because this is, it requires a graph paper, and you need to model these vectors and calculate it. The second method we can use is trigonometry method. In trigonometry method, we need to use the cosine rule for triangles. This we will cover more in detail when we do the trigonometry lesson. Basically, here if you say this is A and this is B and this side is C, then you can find the third side, that is OB, by using the formula C square is equal to A square plus B square plus 2AB cos theta, square root of this. So that is called the cosine rule, which we will discuss in trigonometry. Now there are two activities for us. The first one is, can you figure out how to calculate A minus B for the same vectors? Pause for a minute and think. We did A plus B. Do you know how to do A minus B? Well, if you figure it out, you're on the right track. We go ahead and model OA as before. And for modeling minus B, it is just that we take the same 10 newtons, but in the opposite direction. Here we had taken it along plus x. Here we take it along minus x. The remaining thing is the same. We need to complete the third side of the triangle and find out what this length is, OB. And we are done. The second activity for us to think about is, do you think commutative law holds true for vector addition? That is A plus B is equal to B plus A? Well, if you say the answer, it holds true, then you are right. A plus B is equal to B plus A. Addition of vectors, the second method, as we discussed, is the parallelogram law. So here we model the two vectors as two sides of a parallelogram law, a parallelogram. In our case, OA is the first vector and OB is the second vector, and both vectors have an angle theta between them. Now, what the parallelogram law asks us to do is we need to complete the parallelogram by drawing the other two sides. Here, we need to draw a line which is parallel to OA and another line which is parallel to OB. So we have AC and BC as the two sides of the parallelogram law. Parallelogram law states that OC is the resultant. of the two vectors. That is, it says A plus B is nothing but OC. Essentially, we need to find out the length of OC, and that would represent the resultant. How do we do that? We have a small construction that needs to be done. We have to drop perpendiculars from C onto OB extended, right? And this length is D, and this length we will call it as C. Now, what we can say about this triangle ODC, ODC is, or OCD is nothing but a right angle triangle, and we can use the Pythagoras theorem, and Pythagoras theorem will state that the square and the hypotenuse is equal to the sum of the squares of the other two sides. OC square here will be equal to OD square plus CD square. Remember, OD is this entire length. Right, now if you see, OD is nothing but OB plus BC, which is B plus C. And CD for us is D. So from this triangle BDC, what we see is that this also is a right angle triangle, and we can represent this side C in terms of A, because A is known for us, theta is known for us, C is something which we took for convenience. We have to express C in terms of A and theta. So C will be A cos theta, and in the similar fashion, D is going to be A sin theta. So having expressed C and D in terms of the knowns, we can populate them out here. We get OC square is equal to OD, it was nothing but B plus A cos theta whole square, and CD is nothing but A sin theta whole square. We expand it, we find out that A square cos square theta, A square sin square theta are present. We can simplify them and get the result as OC square is equal to A square plus 2AB cos theta plus B square, or OC is the square root of this. Okay, so what we have essentially found is the magnitude of this diagonal, the length of this diagonal, which is given by this formula, square root of A square plus B square plus 2AB cos theta. We must remember that this is not complete. We need to find the direction of the resultant. Means we need to find out the angle phi. We need to come out with an expression. Once again, this triangle is a right angle triangle. If I want to specify phi, I can use the ratio tan phi is equal to CD divided by OD. Therefore, we can say tan phi is equal to CD is nothing but D and OD is nothing but B plus C, or D was nothing but A sin theta divided by B plus A cos theta. So with this, we have completed both the methods of adding two vectors. From physics perspective, we must realize that whenever we are talking about two vectors acting co-initially, as in the case of a body being pulled by two people simultaneously, can be modeled using parallelogram law of vectors. Whereas in the case of triangle law, most of the numericals around relative velocity. In physics, in the first chapter, we would encounter problems like rain is falling vertically with a velocity of 30 meters per second, and a man is running towards east with a velocity of 10 meters per second. What is the relative velocity of rain with respect to the man? So in those cases, we can model the velocity of the rain and the velocity of man as two different vectors and represent them as two sides of a triangle. Okay, so that is how triangle law can be utilized for solving such problems. Whereas in the case of two forces acting on the same body, it is a case of co-initial forces. I mean, both the forces are starting off from the same point, and we can model the problem using parallelogram law of forces. Essentially, from a mathematical perspective, the solution is by and large the same, whether it is parallelogram law or triangle law, the way we go about finding the third side, the resultant is one and the same. So as a part of our understanding, let's quickly try these numericals. I encourage you to do that. Two forces, 5 Newton around y-axis and 10 newtons along x-axis are acting on our body. What is the net force? And what is the direction in which the body will move? And there are 3 forces which are acting on a body of mass 5 kg. And you're supposed to find out the net force on that body. Okay, the magnitude of forces are specified here along with the angle. And the third question is that a body is being pulled by 2 forces in this way. One force is along x-axis 4 Newton, another force is 3 Newton with an angle of 60 degrees. The mass of the body is 5 kg. We need to find out the acceleration of the body. I urge you to try these numericals, and we will discuss that at the beginning of the third and concluding video lesson. Now, as we discussed, there are more ways to represent the vectors. For example, let us look at a graph in which we have a point, and the point is 4, 3 in the xy Cartesian plane. So, O being the origin, OP can represent a vector. What is the magnitude of OP? We can find the magnitude of OP by using the Pythagoras Theorem. And it is easy for us to say it is 5 units because this dimension is 4, this dimension is 3. This will be square root of 16 plus 9, which is nothing but 5. We denote the magnitude by using this symbol. It is like absolute value. Absolute value of OP vector is nothing but 5 units. What about the direction? Once again, this is it is in XY plane and having only 2 points, x, y. So the angle can be found out by using theta is equal to tan inverse of this side, which is 3 units, divided by the base, which is 4. Tan inverse of 3 by 4 will give us the direction of vector OP. At this point, we should also discuss about unit vectors. So what are unit vectors? If I have the XYZ planes, I am going to call I as the unit vector, which shows a vector of magnitude is equal to 1 and which is acting along x-axis. And if I have a vector acting along y-axis with a magnitude of 1, I'm going to call that as vector j. And similarly, vector k along z-axis. The advantage of this is I need not say all the time force of 5 Newton acting along x-axis. Instead of that, I can say a force of 5I Newton. So 5I would mean that the magnitude of the force is 5 and it is acting along x-axis. Likewise, I could say I'm throwing the ball, instead of saying vertically upwards with a velocity of 10 meters per second, I could say I'm throwing the ball with 10j meters per second velocity. So 10j essentially means the body is being thrown vertically upwards. So using this representation, I could say OP is 4 along x-axis, 4i, 3 along y-axis, 3j. And as we mentioned, I and j are nothing but unit vectors along x and y. Likewise, if I have a point P1, how do I represent that vector? I have OP1. OP1 is nothing but 10, 14. Therefore, OP1 would be 10i plus 14j. Likewise, OP2 would be minus 7i plus 5j, and OP3 would be minus 5i minus 5j, and OP4 would be plus 6i minus 5j. So in this way, we can represent, this is the second way to represent vectors. We have another quick check assessment. What is the angle made by the vector 3i plus 3j with respect to x-axis? Angle made by the vector 5 root 2i plus 5j with respect to x-axis. And if vector a is equal to 3i and b is equal to 5i plus 5 root 3j, what is the magnitude of a plus b? Or what is the magnitude of the resultant and the direction of the resultant? So with whatever we have learned, I urge you to work on these numericals, and we will see how to do this in the third video. I hope you have understood this lesson. Happy learning. Thank you for watching. Bye.